Chapter 4, Section 6. They basically everything we've learned so far about multiplying polynomials, you could apply and actually do this. They focus in on some special products, not necessarily that you just learn a shortcut to multiplying faster, which is not a bad thing. If you can skip some steps, you're going to reduce the amount of chances for error. That's always a good thing, as long as you understand what's going on. But the main reason for these special products is when we get into factoring. So when we're going to basically go the other way, I'm going to show a resultant, usually a trinomial, that we'll focus into, and I want to be able to recognize how I could break that into a multiplication of two things. Think about that while we're going through this, because they're going to show us a couple things that and set up some terminology and those kinds of things which are going to help us mostly in factoring, or taking something and breaking it into multiplication of two or multiple things. Okay, that's what factors are, parts of a multiplication. So these are really factors here. This x plus 5 right here and x plus 4 are factors. They're parts of a multiplication. Now it's a sum in there, that's an addition, but when we're focusing in on the parts that are multiplied together, we're looking at those factors. And they talk about using that distributive law like we did and talked about in section 5. They go through this and they say, hey, this middle terms here we can add those things, or they're like terms. They're going to set up a method using a mnemonic, really, of FOIL, which is first, outer, inner, last. And if you do it in this order, which I think you would do anyhow, if we had two binomials multiplying and what we went through in section 4, you'd probably come out with these middle terms being like terms, and you can add those together, those kinds of things. But like I said before, this is a good thing to remember when we go through factoring. We're going to use something called anti-FOIL in next sections and chapters. Okay, so FOIL stands for first, so I take first times first, x times x in this case. This is the first term of the first binomial and the first term of the second binomial, so first times first. Outer, so when I put this in here, I have an outer term here, x, and this outer term of 4. So I got x times 4. Inner means the inner two, the ones that are close together here inside this thing right here, and then last times last. So I get this FOIL. They show this a couple different ways. Okay, not that crucial for actually getting your product or the result of this multiplication, but will become more important here when we get to factoring. So I can use this anytime I have a binomial times a binomial. It doesn't matter what term or degree each term is. I can use this method of first times first, outer times outer, inner times inner, last times last. So they show some examples here. And notice, here these two middle terms are like. I can actually add those 4x plus 7x. So the simplified expression here, this trinomial, a three-term expression, would be written like this. Okay. Now here we have a case where even though I have different degrees of the terms or higher exponents, same idea works. Okay. So that's FOIL. Now here is another real special product, and if you just FOIL this, when I have, like in this example, x plus 5, the quantity times the quantity x minus 5. If I use FOIL on that, I take first times first, I get x squared. Outer times outer, I get a negative 5x. Inner times inner, I get a positive 5x, excuse me. And outer, or last times last, the L on FOIL, I get a negative 25. Well, these middle terms go to 0. Negative 5 times 5 is 0 times x is 0, right? If I use the distributive property, this is really negative 5 plus 5 all times x, or 0 times x is 0. And I end up with this binomial here. of x squared minus 25. Okay? Well, this product of a sum and a difference, in other words, the terms are pretty close the same. The first term and the second term are close. One is a opposite, right? One is a addition, one is a subtraction. We can use a shortcut which is closer than FOIL. It's called the difference of squares. And you need to remember this. Recognizing this is very important when we get into factoring. So this difference of squares. So I have this and this is same A and B, right? A and B. One is a addition, one's a subtraction. I'll end up with the first term squared minus the second term squared. Like this one is x squared. Well, 5 squared is 25, right? So x squared minus 5 squared. That's a difference of squares. Can be a real good shortcut. So if you recognize that, I would be disappointed, and you should be too if you have to fall onto FOIL, is recognize this pattern as difference of squares, write the first term squared minus the second term squared. In this case you get x squared minus 16, so on. Now squaring binomials is a similar deal where I have the same binomial to the 2 power. That's squaring it. That's a nickname for the 2 power, which means that x plus 3 is times itself, or it's a factor twice, right? Now I could use FOIL and find this, and I'd end up with this result of x squared plus 6x plus 9. And I would say, you know, it's not much more difficult, and really isn't. In fact, if I'm in a test, I would probably still check this to make sure, just by writing it out, to make sure I got the right answer. Same thing with a difference in here that's squared, like a minus 7. The only thing here that happens, here I ended up with 2 of the 3 x's. Here I get 2 of the negative 7a's, which is a negative 14a's. That's the pattern they want you to recognize. Like I said, this is really about factoring. We want to get to the point when I see this, I should be able to take and say, and this is, you have to remember this. Again, I'd say it's not that important for multiplying, because it's not that hard to multiply that. Just go A plus B the quantity times A plus B the quantity. FOIL it, and you're going to end up with this. Same thing here. FOIL it, you're going to end up with this. But why they're doing this is so you recognize when you see something like this, it's the first term squared and the last term squared, and if this middle term is this times this doubled, then this is a perfect square trinomial, which means when I get into factoring, I should be able to get to say, hey, this pattern exists, I can write it like this. Really works the same way here too. First term squared is a squared, right? Last term squared, which would be negative b squared, is a positive b squared. Remember, it would be negative b times negative b, positive b squared. Well, if I take a times negative b and double it, I get a negative 2ab. So it works the same way, okay? And that's what they want you to practice, and this is part of the assignment, is to say, look at this and say, this is x squared plus x times 7 times 2, or doubled, 14x plus 49. Look at this one, it's t squared plus a negative 10t plus 25. Okay? Just by applying these patterns to it, hopefully you can do this that quickly. And if you have to write this out every time, you're missing a real key component of applying this. And a good way to remember formulas, this is really a formula, is to apply it when you're working on these questions. If you don't apply it, I don't think you're going to remember this part when you need it. So apply it while you're working on your assignments and do that. And that's what they're showing here. They say, hey, I got a plus b squared. I got that pattern, right? This is a perfect squared trinomial. Comes out as first term squared plus 2 times the 2 terms multiplied, which would be 2 times x times 7, and the last term squared, which is 7 squared. Okay? Now there's some cautions in here because we tend to want to not have to deal with that kind of complexity or end up with these trinomials. It's very easy to say, hey, I kind of wish it was like this, right? If I have a times b squared, I end up with a squared b squared. But this is an addition. That's a different deal. It's not going to ever end up that you can just distribute this exponent over an addition. Different operations doesn't work. That's why they bring up these cautions here, usually errors that happen. And you can check this. If you're not sure, I could say, well, let's take like 7 plus 5 to the 2 power. Well, that's 12 squared or 144. Well, if I tried to do this thing right here, I would say, well, then 7 squared plus 5 squared should equal the same thing. But it doesn't even, it's not even close. It does not work, okay? This is simply if you're not sure, put some numbers in there and see if what you're thinking will actually apply. Now here they go drawing pictures again. And if I have a plus b times a plus b, instead of this being a rectangle, it's a special rectangle, which is a square. A square is a special rectangle. It's a rectangle with equal sides, right? Well, I can draw this picture. I can say, well, one side's a plus b and the other side's a plus b. Well, here's a plus b, here's a plus b. Well, then I look at the different rectangles that will happen in here. And I end up with this rectangle, the area of that's a squared. I have an AB, an AB, and a B squared. Well, it's two of those ABs, right? And that's the pattern they want you to recognize, okay? This is a nice little type of question here, and I really like this. If you can get visuals, again, I keep saying this, if you can get a visual attached to some of these things that are going on here. So they got x plus 2, the quantity squared. So I look at this thing and say, well, which diagram illustrates this? Well, I'm looking for sides that will be x plus 2. Well, here's x plus 2 and here's x plus 2. So this diagram basically represents A here. And then I'd end up, I could count this. Well, this area is x squared, this is 2x and 2x, and this is 2 squared, or 4. So I could say, hey, right here, B is the answer to this little A, okay? Then they go into multiplication of various types. Remember, the focus right away was on these special kind of products where we have a FOIL, right? We go through, if I have a binomial times a binomial, and then they went through difference of squares, and then squared two-term things, or squared binomials. Well, it's all kind of summarized here. Now, if I can't do these things, in fact, I should look for these first. It says, well, let's look at this is strategy, really. These aren't new laws or anything. None of this is really new. It's all using the distributive and pointing out that there's some patterns that can be used to identify some things to make this easier to do. And again, when we get to factoring, it's going to be very necessary to understand this. So when we're multiplying two polynomials, is the multiplication a product of a monomial and a polynomial? If so, just distribute that. You multiply the monomial times each part of that polynomial. Number 2, is the multiplication a product of two binomials? We've gone through 3 types of special cases with binomials, and we'll run into this a lot. So they have 3 special cases. One is, do they end up having a difference of squares situation here like this? If it is so, then you should be able to write directly as something the first term squared minus the second term squared. Is the product a square of a binomial? Do you have something like this? And if it does, it follows this pattern. And really, when I think about this, I don't even have to really remember this, because if I have a minus b, I take a squared, I get a squared, right? I take the last term squared, b squared, which is negative b times negative b is a positive b squared. Well, a times negative b is a negative ab. You double that, I get 2 of those, I get a negative 2ab. It's the same thing I do here, okay? And then if these two situations don't occur in that, then we look for FOIL. First, outer, inner, last, okay? And then it says if the multiplication is a product of two polynomials other than above, then we basically use the distributive property. And they talk about setting up columns is a great way to organize your work. It's a very good strategy, and will hopefully will reduce the amount of errors. And that's it. Again, I can't emphasize enough that it's important to remember these special products, especially when we get into factors.